This is RD Sharma solution, class 12th, chapter 11. Differentiation exercise is 11.3. Now, differentiation. Now, this is the interval, and most of the people are asking why this is being considered, and why just not differentiating tan inverse, making something tan inside, and just solve it. So I would like to add to it, and people were asking also, so I'll just tell you that there is a range, there is a boundary. If you have a sine inverse and you have a sine inside, the theta will only come out, that is x inverse into x, normally we consider is 1 by x into x, so we cancel it, we say it is 1. So in the same way, analogy if you make, if theta is coming out, by an analogy that sine inverse sine can be cancelled out. But it will not come as theta just by choice. The theta will only come out with certain thought about the trigonometric functions. If theta is between minus pi by 2 and pi by 2, these both are included, then only theta will come out. For example, if it would have been sine inverse, then you need to check whether whatever you have thought, y equals to sine theta, y equals to cos theta, whichever you think you have thought, that has to be between these limits. For example, cos inverse and cos theta, same thing. When you cancel these, you get a theta. How do you get a theta? You don't get theta always. That theta should be between 0 and pi. Then only you can have cos inverse cancelled out. And this question is tan inverse. So if you have tan inverse or tan inverse tan, that theta will come out only when the theta is between negative pi by 2 and pi by 2. So in sine it was inclusive, here it is not inclusive. So if you know the graph of sine cos tan, then you will be able to tell, oh yes, this is correct. Similarly, we have for sec, cosec, cot, when we can cancel it, when we can assume it to be a kind of inverse thing. So this question is important, but the range and the boundary also check is vital to solving this question. Okay, when I told this and I took some more time in solving the question, people have disliked like anything. Anyways, let's come down to this question, and there are multiple questions like this. So this is two things. One more time I am telling you that differentiation is one thing, but differentiation of a trigonometric function always should be inside the limits or boundaries, because you cannot have differentiability everywhere. So for those who want to understand, I'm going to tell them, and those who just want to see the reference, there is a reference answer here. Okay, whenever we solve this kind of questions, we always see whatever is inside the root. So you have root 1 square minus x square. 1 square is a here. So when you have under root a square minus x square, you always put x as a sine theta. Sometimes you also put it as x equals to a cos theta, because sine square theta plus cos square theta is 1. Since a is 1 here, x is sine theta we are putting. So this is sine theta. The inside one I am telling you. X is sine theta. 1 plus under root 1 square minus x square, that is 1 minus sine square theta. So you have a sine theta here. 1 plus 1 minus sine square theta is cos square theta. And when you have a under root of cos square theta, it will be cos theta only. Now sine theta can be written as twice of sine theta by 2 cos theta by 2, because sine 2 theta is 2 sine theta cos theta. When you have a theta, it will be theta by 2. So you have 2 sine theta by 2 and cos theta by 2. This is cos theta by 2, okay? And 1 plus cos theta will be what? It will be 2 cos square theta by 2. These inequalities and results should be in your tips. 2 cancel, cos 1 cancel, sin by cos, so it will be tan. tan theta by 2. Finally, you got tan theta by 2. So this is tan inverse. And then we have this tan theta by 2. Tan inverse tan theta by 2. So tan inverse, you can cancel these out. But finally tan inverse will cancel out and theta by 2 will come. Theta is basically sin inverse x. So you have to differentiate sin inverse x by 2. So y is sin inverse x by 2. You have to differentiate it. Sin inverse x is simply 1 by under root 1 minus x square. You have a twice here. So this is your final differentiation. I am not denying that. And you will get a proper answer here. So what is the value of this negative 1 and 1? Why we have this? Because this x is the sin theta you have introduced. So you have to show the examiner that I have a check. And then the result may vary if you don't check. Sometimes it may come as when you take this out, it will be pi minus theta, pi by 2 plus theta or negative theta, So now this sin theta is between negative 1 and 1. Because you have taken y as this x as sin theta and x is sin theta. So you put sin theta here between 1 and minus 1. Now what is the value of theta for which the sine is negative 1? What is the value of sine for which the value is 1? So this sine inverse minus 1 and sine inverse 1, you will get pi by 2 and minus pi by 2. You know that? Sine pi by 2 is 1 only. So sine inverse, you can write in place, so sine inverse 1 pi by 2, sine inverse minus 1 minus pi by 2. So when we have theta by 2, because you need to differentiate theta by 2, make it as theta by 2. So it is between negative pi by 4 and pi by 4. And I just told you that tan inverse is only possible when there is a periphery inside which it belongs. Then only this whatever is inside, here we have theta by 2 inside, that will come out without any addition or subtraction to it. So if it is between negative pi by 2 and pi by 2, these two not inclusive, then this minus pi by 4 and pi by 4 is inclusive in this interval. So there is a big range and this small range minus pi by 4 and pi by 4 is a part of it. You can differentiate it. So this is how differentiation will be done, and that is your answer. I hope you got the idea. Okay. So here we have tan inverse x by a plus under root a square minus x square, and x should lie between negative a and a. Alright. So we have, don't worry about anything, just see the root. Root is a square minus x square. So x is a sin theta. That is what you have to put. I am just saying that refrain from putting x as a cos theta because there may be addition to the complexity. So always write x equals to a sin theta. A is valid here. So a square minus a square sin square theta. Inside one I am telling you a sin theta by. So a sin theta a plus. This is going to be a square 1 minus sin square. So it is going to be a square cos square under root of this. So a cos theta will come out. So a you can take common here. So you have a sin theta and you have a take common 1 plus cos theta. So a is exactly same thing which we just encountered in the previous question. Sin theta is 2 sin theta by 2 cos theta by 2. And 1 plus cos theta is 2 cos square theta by 2. 2 gets cancelled. This cos cancels. Sin theta by 2 cos theta by 2 is tan theta by 2. So this tan theta by 2, this is just the simplification. We haven't started the differentiation as of now. So tan inverse tan theta by 2. So you can just cancel this tan inverse. Theta by 2 will be there. Theta by 2 differentiation. Theta you just replace it by sin inverse x by a. But the range is negative a to a, x should be between this. What is x from here? It is a sin theta. This is a sin theta. So in order to put this x, divide everything by a. You need x by a. X by a is sin theta in your case. You have chosen that already. So this is negative 1 and 1. And same discussion what we had just now in the previous question. This x by a, on the left you get minus pi by 2 and right one will be pi by 2. So what is the what is the value of sine 1? What is the value of sine negative 1? No, sine inverse 1 is pi by 2. Sine inverse minus 1 is minus pi by 2. So this is theta by 2. So now divide also by 2. So you get minus pi by 4 and pi by 4. With the same discussion, this minus pi by 4 and pi by 4 is lying between the range which we need to cancel this tan and tan inverse, that is minus pi by 2 and pi by 2. So this is in between that, inside this. So this range is valid. So you just don't worry about anything addition or subtraction to theta by 2. Just bring theta by 2 outside, cancel tan in tan inverse, and theta by 2 is, we have to differentiate theta by 2. So y equals to theta by 2. But you cannot differentiate theta. Theta is being introduced by you. You have to convert it into x. So theta will be sine inverse x by a from what we have chosen. So sine inverse x by a, and there is a 1 by 2 also. When you differentiate this d by dx, half will come outside. Sine inverse x by a will be 1 by under root 1 minus x square, that is 1 minus x square by a square. So this denominator will be a square minus x square by a square in the under root, and differentiation of x by a is of course 1 by a. So this is a square minus x square by a square minus x square, under root goes up, under root a square goes up, under root a square goes up, a will come out, under root a square minus x square in the denominator, 1 by a is there, 1 by 2, a gets cancelled, 1 by twice of under root a square minus x square is your final differentiation, 1 by twice of under root a squared minus x square. Alright. Differentiate sine inverse. This question and the next question, they are exactly same, almost similar. Alright. So what you will understand here, how to solve this, it will be valid and have similarity with the next question. So you have to just go through the under root 1 minus x square, so it is 1 square minus x square, equated with a square minus x square, under root a square minus x square. So just put x as a sine theta. So x is a sine theta, a is 1, that is why I am not writing it, a is 1 here. So x is sine theta you have to put. So theta will be equal to sine inverse x, because ultimately you have to differentiate this only whenever the theta comes out, when you cancel sine and sine inverse. Now let us go inside and solve this first. Inside what I am doing, x is sine theta we have chosen, plus under root 1 minus x square is sine square theta, 1 minus sine square theta, and divided by root 2. This is under root 2. Okay, sine theta and under root 1 minus sine square theta, 1 minus sine square theta is cos square theta, so cos square theta under root is cos theta only. And you have root 2 in the denominator, so sine theta, this is root 2, so this is 1 by root 2 plus cos theta, this also 1 by root 2. Now you can take this first one as cos pi by 4, second one is sin pi by 4, because sin pi by 4, cos pi by 4, sin 45 degree, cos 45 degree. They are 1 by root 2, they are the same number. So I am writing sin theta, in place of 1 by root 2 I am writing cos pi by 4 plus cos theta, and this is 1 by root 2, so I write it as sin pi by 4. So sin a cos b plus cos a sin b, that is simply sin a plus b. So sin theta plus pi by 4. And you have a sine inverse outside also. So sine inverse we have taken from here, and if you want to cancel these out, you have to be very sure that it should lie between -1 and 1. And we know what is the boundary and limit of trigonometric functions also, or identities also. So x is what? Sin theta. So sin theta is between -1 and 1. That means it is between minus pi by 2 and pi by 2. You can assume it to be, just add sine inverse. You will get the proper solution, sine inverse x. So this is minus pi by 2 and pi by 2. And now you need theta plus pi by 4 to be checked. So in order to check this theta plus pi by 4, just add pi by 4 on both the sides. All the sides basically. Theta plus pi by 4 has to be added to every element. Theta plus pi by 4 also will be there. So pi by 2 plus pi by 4 will be, see, whenever there is an issue, you are not able to get the LCM, multiply 4 and pi, 4 pi, 2 and pi, 2 pi, and multiply the denominator now, 2 into 4, 4 to 8, 6 pi by 8, that is 3 pi by 4 it is. So 3 pi by 4. Now right here 3 pi by 4. And this is between pi by 4 minus pi by 2 is of course pi by 2, pi by 4 only. Pi by 2 is a bigger number. So minus pi by 4. Now minus pi by 4 and 3 pi by 4. That is, it is between minus pi by 2 and pi by 2 that we already needed. Minus pi by 2 and pi by 2. So we have to deal with theta plus pi by 4 without worrying anything. So this is the limit. We are inside that, so we don't have to worry or be concerned about that. So now this theta or theta plus pi by 4 is between negative pi by 4 and 3 pi by 4, which is acceptable. So just have to differentiate theta plus pi by 4. Why is theta plus pi by 4? Because theta is introduced by you, so you have to convert it into x. So I told you theta is sine inverse x. It is sine inverse x plus pi by 4. You just have to differentiate this dy by dx. So this is pi by 4 will be 0. Sine inverse x will be 1 by under root 1 minus x square. That is your final answer. Now as I told you, this is also similar to the previous question. The boundary is also the same. So same result is going to come. Same process should be followed. And what we'll do here is x equals to sine theta we'll put. Because everything depends on what is inside the under root 1 minus x square. So assume it to be under root 1 square minus x square. So it is equivalent to under root a square minus x square. Whenever you have this x, normally we put as sine theta. X is equals to a sine theta. A is 1 in this case. But people are solving using x equals to cos theta also. That will just add some a bit of complexity, but you don't have to worry about it. Just always put, whenever you get this, x as sine theta. That has to be de facto. This use as de facto. Okay. So now the inside one I'm telling you, when we put x as sine theta, so sine theta plus under root 1 minus sine square theta divided by under root 2 you have. So you have sine theta plus 1 minus sine square theta is cos square theta. Because sine square theta plus cos square theta is 1. 1 minus sine square theta is cos square theta. Under root cos square theta is cos theta only. This is cos theta. So you have sine theta plus cos theta and divided by root 2. So root 2 you can take separately. And what do you get? You get sine theta 1 by root 2. In place of 1 by root 2 you can have sine pi by 4 or cos pi by 4. But we have to make a formula out of it. Because sine 45 degree, cos 45 degree, sine pi by 4, cos pi by 4, all are 1 by root 2 only. So in place of 1 by root 2, you can put any value which you need. But we need to make a formula. Remember, sine theta 1 by root 2 is sine pi by 4 we are writing. And then we have cos theta. And this 1 by root 2 I am taking it as here cos pi by 4. So sin A cos B plus cos A sin B, or cos A cos B plus sin A sin B. They both comes down to cos A minus B. So our final will be cos A minus B, that is theta minus pi by 4. So this is just a simplification I am doing. I haven't even started the differentiation. So cos A minus B is the formula here. And now we'll bring that cos inverse, because this is the inside stuff I was telling you. So cos A minus B, and this is theta minus pi by 4. So this is the simplification. Now this is the part which we have done. So you have to add this cos inverse because it is outside. So cos inverse cos theta minus pi by 4. So this cos inverse you can just cancel, but that is only possible when you have a limit. That is, it has to be between 0 and pi. So what to do? You will see in this question, if you don't consider negative 1 to 1, what will be the problem that is going to arise? Because you will not get the proper solution here. Because, see, minus 1 and 1, this is where the x should be inside. Minus 1, 1 not included, please remember. Now, you need some, x is actually sin theta you have put. So, in place of x, just replace it by sin theta. So x is sin theta between negative 1 and 1, and we already know what is that. It is between pi by 2 and negative pi by 2. So negative pi by 2, it is pi by 2, and this is sine theta between negative pi by 2 and pi by 2. Okay. Now this is a theta basically, not sine theta, it is theta, because assume it to be that we have applied sine inverse all the sides, all the content here. So negative pi by 2 and pi by 2. But you need theta minus pi by 4, that is inside. You are checking that only, no? So theta minus pi by 4, so you have to subtract theta by this pi by 4 on all the sides. So minus pi by 2 minus pi by 4, theta minus pi by 4, and pi by 2 minus pi by 4. So this is minus 3 pi by 4, and this is theta minus pi by 4, this is pi by 2 minus pi by 4 is going to be pi by 4 only. Now this is the limit which is inside 0 and pi. Or no, this is not between 0 and pi, because you have gone ahead of that or outside that. Alright. So here there is, whenever you take this out and there is a limit which you are surpassing. So cos and cos inverse, when you cancel, this will be negative of the theta, whatever is going to come inside. So it will be negative of theta minus pi by 4. I hope you got the idea. Simply, if you do it directly, you will get theta minus pi by 4 and you will start differentiating it. No, it will be negative of theta minus pi by 4. So minus 3 minus theta plus pi by 4. Theta is of course your sine inverse x plus pi by 4. So why is this? So dy by dx is minus sine inverse x is 1 by under root 1 minus x square. Differentiation of pi by 4 is going to be 0. So this is how negative of 1 by under root 1 minus x square will come after taking care of all the limits and all the boundaries which is provided in this question. Okay, next question we'll do later. Thank you so much. Take care of yourself.